Now I hope you understand what is the meaning of row becomes 0. Why the row is becomes 0 and the row will become 0. Now what happened, the situation and how the poles are arranged and all these things you can easily understand. Okay. Now we'll solve another question. Now this is the characteristic equation of order 6. Now this is the characteristic equation of order 6. Now this is the characteristic equation of order 6. Then we will do our normal procedure. Now s power 6 is an odd power. Write all the odd power quotient, even power. Write all the even power quotients. 1, 4, 5, 2. Now s power 5. Now the s power 5 is nothing but an odd power. Write all the odd power quotients. 3, 6, 3, 0. Now from the third row onwards we need to find the quotient. Now this is the third row, which is nothing but s power 4. 3 into 4, 12. 12 minus 6, 6 by 3, 2. 3 into 5, 15. 15 minus 3, 12. 12 by 3, 4, 0. Sorry. 3 into 2, 6. 6 minus 0, 6 by 3, 2, 0. Now see here. Now s power 3, s cube. 2 into 6, 12 minus 12, 0. 2 into 3, 6 minus 6, 0. Now 0, 0. Now what happened now? One complete row becomes 0. I hope you already understand the meaning of that. Whenever one complete row becomes 0, now which means that definitely the poles are arranged symmetrically in the S-plane with respect to origin. Am I not? Now the poles are arranged symmetrically with respect to S-plane on origin. Now see here, this is the poles are arranged symmetrical. Now the reason behind is auxiliary equation. Auxiliary equation is nothing but even number of poles. So what is the even number of poles? Auxiliary equation is s power 4 plus 2s power 4 plus 4s square plus 2 is equal to 0. Now you differentiate this auxiliary equation. Now the differentiation of this main auxiliary equation and equal to 0. Therefore now 8s cube plus 8s plus 0 equal to 0. Therefore now this is 8, this is 8, this is 0, 0. Now continue the RH tabular form. Okay, you continue the RH tabular form. Now s power 2, 8 into 4, 32 minus 16. 32 minus 16 by 8, 2. 8 into 2, 16. 16 minus 0, 16 by 8, 2, 0, 0. Right not? Now continue the tabular form. Now s power 1. Now this is s power 1. 16 minus 16, 0, 0, 0, 0. Now again the second time the row becomes 0 is here. But this second time the row becomes 0 after replacing the quotients with main auxiliary equation. After replacing the quotient with main auxiliary equation. That's why this is called as a main auxiliary equation and this is called as a second auxiliary equation. Now what is the second auxiliary equation? This is the second auxiliary equation. Now 2s square plus 2 into s power 0 which is equal to 0. Now this is a 2s square plus 2 is equal to 0. Now again differentiate the auxiliary equation. Now the differentiate the second auxiliary equation with respect to s and equal to 0. Now this is 4s plus 0 equal to 0. Now replace the quotients. with differentiation of the auxiliary equation. Now this is 4, this is 0, 0, 0, continue. Now s power 0, 4 into 2, 8 minus 0 by 4, which is equal to 2. And you know that the last row first element is a constant in the characteristic equation. Therefore all these calculations are correct. Okay. Now see the first column. Positive, 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 positive. All are positive sign, all are same sign in the first column, and don't say the system is stable, because this is a case where the row of zeros occurs. Okay. But now I just give one shortcut method previously. What is the shortcut method I am giving? Again, I just repeat the same shortcut method and we will try to do the analysis. Shortcut. What is the shortcut method? If more than once a row of zeros occur, if more than once a row of zeros occurs in the RH tabular form, if more than once a row of zeros occurs in the RH tabular form, if more than once a row of zeros occurs in the RH tabular form, if more than one time only one time the row of zeros occurs, you are saying system is marginally stable. If more than one time the row of zeros occurs in the RH tabular form, means one time means imaginary axis, but more than one time means repeated. Repeated means system is unstable. Closed loop control system is unstable. Not only that, there may be also another condition. That second condition is all the first column quotient should be positive. If all the first column quotient should be positive, and if more than once the row of zeros occurs in the tabular form, closed loop control system is unstable, because a poles lies on imaginary axis which are symmetrical but which are repeated. Understand? Or which are repeated. Now see the situation here. Then if you this is correct or not, you can again rectify with this. Now there are two auxiliary equations. So you want to find the roots of main auxiliary equation, because the second time the row of zeros occurs after replacing the quotients with the first auxiliary equation. Okay. The second time the row of zeros occur after replacing the quotient with the first auxiliary equation. Therefore take the first auxiliary equation and decided the system performance. Therefore, what is the first auxiliary equation? The first auxiliary equation, and only one auxiliary equation here, is 2s power 4 plus 4s square plus 2 equal to 0. 2 take it as a common. S power 4 plus 2s square plus 1 equal to 0. Therefore, s square plus 1 whole square equal 0. A square plus b square plus 2ab. Therefore, what are the roots? S square plus 1 equal to 0. Therefore, s equal to plus or minus j1. Similarly, again s square plus 1 equal to 0. Therefore, s equal to plus or minus j1. The poles which lies on imaginary axis, one is plus j1 and another one is minus j1. Again one is plus j1, another one is minus j1. The poles which lies on imaginary axis but which are repeated, then the closed loop control system is unstable. Repeated poles on the imaginary axis, therefore system is unstable. Now that's why I'm saying the number of row of zeros occur, how many times the row of zeros occurs will give the number of poles which lies on imaginary axis. If the non-repeated poles on imaginary axis there is no repetition of the poles on the imaginary axis which are symmetrical, then one row of zeros occur. Now the repeated poles on imaginary axis with respect to symmetricity, then that is nothing but the number of times the row of zeros occur. Now here, now with respect to origin symmetrical on imaginary axis, but which are repeated, okay? Now which are repeated, therefore the 2 times the row of zeros occur. But let us say this is only plus j1 and this is minus j1, non-repeated poles on imaginary axis, therefore only one row of zeros occur, okay? Now by looking this also, repeated poles on imaginary axis will give the number of times the row of zeros occurs. The number of times the row of zeros occurs, which will give the number of repetition and non-repetition poles on the imaginary axis. Then you just take this one. Okay, then I will give one clarity of this. Now first you just take this one, okay? This is very important, okay? Now when the row of zeros occur, in which situation the row of zeros are coming, right? How many row of zeros occur, okay? That is also important. Now here is one example I am taking. From here I will start. With respect to origin, the poles are symmetrical. Repeated or non-repeated? Repeated. Therefore, 2 times row of zeros occur because repeated symmetrical poles with respect to origin. This is one example. Now another example is now I just give another example. Plus j1 minus j1. Only one time row of zeros occur because non-repeated symmetrical poles with respect to origin or imaginary axis or anywhere, okay, with respect to origin. And I explain. Then to avoid the confusion, then I am giving another thing also. Now, yes, this is with respect to origin. The poles are symmetrical, but which are non-repeated. Therefore, how many times the row of zeros occur? Here is also only one time row of zeros occur because non-repeated non-repeated symmetrical poles with respect to origin. Therefore, here 2 times row of zeros, here 1 time the row of zeros, here is also 1 time the row of zeros occur. Okay, so repeated poles on imaginary axis or repeated poles on S-plane with respect to origin. Okay, with respect to origin will give the number of times the row of zeros occur. Non-repeated, therefore only 1. Non-repeated, only 1. Repeated, therefore the row of zeros are 2. Okay, note down this. Clear? Now here, now I just give one concept which is called as row of zeros. Now we are in the row of zeros concept. Now this is a very important concept for the GATE examination point of view, for the problems point of view. Okay, so we'll see that concept in detail. Now see here, the row of zeros occur, and we solve the problems, but in all the problems row of zeros occur, but all the first column quotient should be positive. Am I not? We solve the problems, but there is no guarantee of that. Row of zeros occur, or sometimes row of zeros occur, sometimes sign changes is also occur in the first column. Am I right? No? Yes. Now the question is, if sign changes below row of zeros, if sign changes occurs below row of zeros. What is the meaning of that? Means there is a row of zeros, but there is a sign changes in below row of zeros. If any sign changes occur below ROZ, then there exists a symmetrical pole with respect to origin. For example, if sign changes, for example, let us take example, one sign change where below ROZ, one sign change below ROZ. If any sign changes below, I am talking about below ROZ, if any sign changes occur below ROZ, let us take for example one sign change. One sign change means what? What is the meaning of one sign change? One pole is on the right hand side. One pole is on the right hand side. Let us assume this is at somewhere. Okay, for example, this is the example. plus 1. Let us example. Okay, for example, one sign change. Therefore, one pole is on the right hand side. If the sign changes occur below ROZ, which is the meaning of there should be exist a symmetrical pole on the right hand side. There exists a right hand side pole on the there exists a pole on the right hand side. There exists a symmetrical pole on the left hand side. There exists a symmetrical pole which is nothing but -1. When this situation is coming, this situation is coming when the sign changes occur below ROZ. Understand or not? If the sign changes occur below ROZ, then there exists a symmetrical pole on the right hand side. Corresponding left hand side there is a pole. Okay. For example, the same situation. Now two signs. This is the example of one sign changes. This is the example. One sign change. One sign change below ROZ. Now the same situation. Now I am talking about this is the sign changes below ROZ. Now let us take for example. Two sign changes. Now this is only one sign change. Now where this sign change is the below ROZ. Now there is a two sign changes. Whenever there is a two sign changes, what I am saying, then you understand or not? There is a two sign changes. First two sign changes means now two poles on the right hand side of S plane. Let us example, for example, this is -1 and this is +1 and +2. Two sign changes. Therefore, two poles on the right hand side of S plane. Then there exists a symmetrical pole on the left hand side of S plane corresponding to the right hand side of S plane, which means now there exists a symmetrical pole at -1 and there exists a symmetrical pole at -2. Now, when there is a symmetrical poles on the right hand side and left hand side, if there is a sign changes, now these sign changes are available below ROZ. Okay, if sign changes are below ROZ, then there is a symmetrical poles on the right hand side to the corresponding to the left hand side. This is an important concept. Then you understand or not? If any sign changes, poles are on the right hand side, but that sign changes is below ROZ. Now corresponding right hand sided poles, there exist a symmetrical poles on the left hand sided. So then what is the reverse? Vice versa is nothing but if any sign changes above ROZ, if any sign changes above ROZ, then there is no symmetrical pole to the right hand sided pole. There exists a left hand sided. Okay, that also we'll see. First you take this one. Okay. Okay, now the same question I am asking, if sign changes occurs above ROZ, if any sign changes occurs above ROZ, let us take for example, now sign changes occurs above ROZ, for example, one sign change, therefore one pole is on the right hand side, then there is no symmetrical pole on the left hand side, no symmetrical pole. no symmetrical pole. Okay, when no symmetrical pole, when the sign changes above ROZ. Here is also, for example, there are two sign changes. Now let us take two poles on the right hand side of S-plane. Then the two poles on the right hand side of S-plane. There are two poles on the right hand side of S-plane. Two sign changes. There are two poles on the right hand side of S-plane, and there is no symmetrical poles on the left hand side. No symmetrical pole. No symmetrical poles here. There is no symmetrical poles. When this is the situation, if sign changes occurs above ROZ, okay? If sign changes occurs below ROZ, then there is a symmetrical poles on the left hand side for the corresponding right hand side. If sign changes above ROZ, then there is no symmetrical poles on the left hand side corresponding to the right hand sided poles. Okay. Now this two points which are important while solving the problems, then we'll solve the problems now based on this. Okay, just take a copy of this. And one note also, you know that, and one note is nothing but if any missing terms, or negative terms in the characteristic equation, which results closed loop control system is unstable. You know this, okay? If any missing terms or any sign changes or any negative quotients or negative terms or missing terms beyond order 3, closed loop control system is unstable. Okay, you know this point also. Okay, then based on this, then we'll solve a few problems. Now in this question, okay, now this is a question number 1, this is a concept. Okay, now this is one S-plane which is given to you. Now see here, this is one S-plane which is given to you, and what is your answer? Okay, this is one S-plane plus J1 minus J1 plus 1 minus 1. Now you want to tell me whatever you want, whatever you know, you tell me that particular points. I will write it here. Okay, so total number of poles are 4. So the characteristic equation, the highest power in the characteristic equation is 4. Therefore order is 4. Order equal to 4. Is it right or not? Now this is the first point. And the second point is, now with respect to origin, see with respect to origin, now with respect to origin, there exists a symmetrical poles or not? Yes, symmetrical pole, and this is also symmetrical pole, which is repeated or non-repeated? No, there is no repetition. Okay, so symmetrical poles with respect to origin which are non-repeated, then how many times the row of zeros occur? 1 time the row of zeros occur. 1 time the row of zeros occur, because non-repeated symmetrical poles. Am I right? Not non-repeated symmetrical poles. Right. Next, second point. Is there any poles on the right hand side? Yes. How many? 1 pole is on the right hand side. Therefore, how many sign changes? 1 sign change. 1 sign change, because 1 pole is on the right hand side. System is system is unstable. Now system is unstable. Now my question is, now row of zeros occur. This is row of zeros occur and this is sign change. Then just now I am giving one concept, that sign change is below row of zeros, that sign change is above row of zeros. This sign change is coming below this row of zeros and this sign change is above row of zeros. I am asking one more, I am giving already one point. There is a pole on the right hand side of a plane, then there exists a symmetrical pole on the left hand side corresponding to the line. One pole is at +1. There exists a symmetrical pole at -1. Therefore, which means that whenever the symmetrical poles on the left hand sided corresponding to the right hand sided, the sign changes is always below the ROZ. Now, the sign change is existing below row of zeros. Is it correct or not? This is below row of zeros. Now one more thing I am asking. Now the number of symmetrical poles with respect to origin. How many symmetrical poles with respect to origin? Now with respect to origin, the symmetrical poles are, with respect to origin, this is one symmetrical pole and this is another symmetrical pole. So the number of symmetrical poles are how many? There are two symmetrical poles. Am I not? -1 +1. One symmetrical pole plus J1 -1. So the number of symmetrical poles will give the power of the auxiliary equation. Right? Now the question is, the next point is, power of auxiliary equation is 2. The power of auxiliary equation is 2. How you can identify that? Now, which is nothing but the number of symmetrical poles with respect to origin. The number of symmetrical poles with respect to origin will give the power of the auxiliary equation. These are the points. If this S-plane is given and options are like this and wrong option is also available, and all these are the correct options for this particular S-plane. Okay, note down, this is very, very important. No, this is number of symmetrical poles with respect to origin. How many? 1, 2, 3, 4. Therefore, the power of auxiliary equation here is, this is 4. Okay. So the here you write, okay, the number of, this is number of symmetrical poles with respect to origin is the power of the auxiliary equation 1, 2, 3, 4. Therefore, this is auxiliary equation power is 4. For this Okay, then you have a doubt, sir, this is correct or not. Therefore, you can reverse analysis you can do. This from S-plane to we go to the characteristic equation and this is correct or not we can identify. Now, one pole is at, now what is the characteristic equation? Now the characteristic equation is S minus 1 into S plus 1 into, because one pole is at plus 1, another pole is at minus 1. Now S plus J1 S equal, therefore this is S square plus 1, S equal to plus or minus J1. Therefore what is the characteristic equation? A minus B into A plus B, A square minus B square. Now this is A square, then again A plus B into A minus B. Therefore the characteristic equation is A square minus B square. This is the finally the characteristic equation. Is it right or not? Now we will go for the reverse order, reverse direction we will see. Now you just take a problem here. First this problem is just noted down here. One pole is at plus J1, another pole is at minus J1, one pole is at plus 1, another pole is at minus 1, and there is a symmetrical pole on the left hand side and right hand side. Okay, then we'll go for the reverse engineering now, which is nothing but from the characteristic equation. What is the characteristic equation now? Now the characteristic equation is S power 4 minus 1 equal to 0. Now this is the S power 4, which is an even power. Write the even power quotients 1. Now S square 0. Now this is minus 1. Next S cube. S cube is nothing but an odd power 0. Now again S is 0. Now S cube is, now this is 0. Now students, you just see here, this is one complete row becomes 0, right? This is one complete row becomes 0. Therefore, now this is the auxiliary equation, students. Now the auxiliary equation is nothing but S power 4 minus 1 equal to 0. Okay. Now this is auxiliary equation. Differentiate the auxiliary equation. Differentiate this auxiliary equation with respect to S, which is equal to 4S cube. Differentiation of is 0. Therefore, continue the tabular form. Replace the quotients. Now this is 4, 0, 0, right? Now again continue. This is S square. 4 into 0, 0. 0 minus 0, this is 0. Now 4 into minus 1, minus 4. Minus 4, minus 0. Minus 4 by 4, this is minus 1. Therefore, now again here the concept called as, now any one of the first column quotient is 0. Replace that 0 with a smallest possible positive constant epsilon and continue the tabular form. So if you continue the tabular form, now which is nothing but S power 1, now epsilon into 0, 0, minus 4 and minus minus, this is epsilon into 0, 0. Now this is minus minus plus 4 by epsilon. This is epsilon into 0, 0, minus minus plus 4 by epsilon. And this is 0, this is 0. Now this is S power 0. This is x into minus 1, minus 1 into x by x. Therefore this is minus 1. And you know that the last row first element, is a constant in the characteristic equation. This is the characteristic equation, right? Now what is the characteristic equation? The characteristic equation is S power 4 minus 1 equals 0. Now the last row first element is a constant in the characteristic equation, is matching. Okay, right. Now we'll check one by one and all your doubts are correct or not. So the characteristic equation power is 4. Therefore the total number of poles are 4. This is okay. Now see, how many times the row of zeros occur, students? How many times the row of zeros occur? Now only one time the row of zeros occur. This is correct. Now how many sign changes in the first column? How many sign changes in the first column? Now see here, this is plus 1, this is plus 4, this is plus, and here it is also, you can check, replace epsilon with 0, 4 by epsilon, something by 0, 4 by 0, this is plus infinity, therefore this is positive. Now see here, see the situation, positive, 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 negative. How many sign changes? Only one sign change. Only one sign change, student. Therefore, how many sign change? One sign change. System is unstable. Is it correct? Next, this sign change, students, very important. This sign change is below ROZ or above ROZ? This sign change is below ROZ. Then what you are writing? One sign change. Then that sign change is existing below ROZ. Is it correct or not? Yes. Next, where is auxiliary equation? This is the auxiliary equation. What is the auxiliary equation? Power. Auxiliary equation power is 4. So the power of auxiliary equation is 4, which is nothing but the number of symmetrical poles with respect to origin. With respect to origin, 1, 2, 3, 4. 4 poles are symmetrical, therefore, which is nothing but the power of the auxiliary equation. Understand or not? Now there are 4 poles which are symmetrical, that is the power of the auxiliary equation. Then that is also correct. And already right hand side, system is unstable, sign changes, system is unstable. How many sign changes? Only one sign changes. All are correct or not? Clear or not? Now this is the reverse engineering, now which will give the same result. Now if the characteristic equation is given, if solved, I can get this answer. And now S plane is given, and this is the, okay, there is a symmetrical, because the right hand side, left hand side below ROZ. Okay, note down, this is very, very important question. Okay. Now this is the way you can cross check. You move front, you move back side. Okay. You move reverse engineering and you move forwarding, like that. If you understand the concept, you can do anything. Okay. Now you solve by your own for this particular question. Very simple question I am giving. Now plus J1 minus J1 plus 1. Now this is the question. Okay. Total number of poles are 3. Total number of poles are 3. Therefore, order of the characteristic equation is 3. So the non-repeated poles, the non-repeated symmetrical poles. So if the poles are symmetrical, which are non-repeated, therefore one row of zeros, right? Now there is one sign change, because one pole is on right hand side, one sign change, system is unstable. One sign change, system is unstable. But now is there any symmetrical? No symmetrical. no symmetrical here, nobody is here, nobody is there here. There is no symmetrical pole. If there is no symmetrical pole, which means that that sign change is existing above ROZ. Above ROZ, right? Above ROZ. So, the power of the auxiliary equation is the number of symmetrical poles with respect to origin. Now, with respect to origin, how many symmetrical poles? With respect to origin, there is only 1 and 2. There are 2 symmetrical poles. Therefore, the power of the auxiliary equation is 2. So, the number of symmetrical poles with respect to origin, the number of symmetrical poles with respect to origin, 1, 2. Therefore, power of the auxiliary equation is 2. Clear or not? Okay. Note down this students. This is very important. If you have any doubt, go for the reverse engineering. Take this particular thing and again solve it. Then you can get that answer or not. You can check it. Okay. Verify that.